Hey, so now that we have our functions defined and tested to ensure that they are well functioning, we can move on. We'll start by making an array for our pipes. We're gonna call it pipes, and this will allow us to define a lot of the different things about all of our different pipes. So this will incorporate which node it's coming from, which node it's going to, the length of the pipe, the K value of the pipe, and the diameter of the pipe. So our first one will be the node the pipe's coming from. So in the first case, it'll be from node 0 to, and then the second column will be the node it's going to. So it'll be 0 to 1. Then it'll be the length, and this pipe is 20, and then the K value is 1, and the diameter is 0.1. So now we have our first pipe defined. Now we can move on. If this next one is from 0 to 2, the length is 30. The K value is 1, and the diameter is 0.01. Now we'll move on to the next pipe, which is 1 to 2, and 1 is 5. K value is 1, and 0.01. The last pipe. Our next one is 1 to 3, with K value of 0.1, pretty short. With a length of 0.1, it's a pretty short pipe. You have another. This K value is actually one that we were given a guess for to help us. So this is the 6. Then we get 0.01 for the diameter. And now we can move on to our last pipe segment, which is node 2 to 3. And it is also 0.1 long. And then K value 1 and 0.01. So you might be wondering, what is node 3? I thought there were only nodes 0, 1, and 2. Well, I'm going to say that the environment will be our node 3, which both nodes 1 and 2 are leading to. So now we can move on to define a few more things. So let's first define the external pressure indices. So we're going to call that external P indices, and those are going to be equal to, well, if you're looking at the nodes, it'll be nodes 0 and nodes 3, and node 3. So now that we have that, we're going to set our external pressures equal. So that'll be that array. We know that the external pressures are 0 and 0 because we are told this. Now, let's see if this seems to be working fine, as long as everything is spelled correctly. So now we can move on to defining what the different columns mean. So we'll start with the from node because that's our first. That will be equal to the pipes array. It'll be the entire first column. So it'll be colon, comma, 0. Because 0 is the first column. That's how Python does it. And we're going to say as type np.int32 to ensure that it is interpreted as an integer. Now we're going to move on to 2node, which is similar. The only difference is that it'll be column 2, which is the 1. And we want to also make sure that that is interpreted as an integer. Now from there, we move on to column 3, which is the length. So it'll be L, and that'll be equal to pipes, colon, comma 2. Now, the two are also pretty easy. That'll be pipes, then colon, comma, 3, the fourth column, and then the last is the diameter for D, and that'll be pipes, colon, comma, 4 for the fifth column, finding our values in those columns. Now, let's see how many pipes we have. So we have the number of pipes. That'll be equal to pipes dot shape. That'll be the shape of the array, and that'll be 0. There. So let's run that. See what we get. 5. Correct. We have 5 pipes. You can see this 5 right here. So now let's set the pipe ED. And in this case, they're all the same, so we can say np.full, and it'll be, the size will be the number of pipes, and the value for each thing will be 0.001. So let's see what we get. And look at that. Okay, so from here, we want to find the number of nodes. It seems fitting because we just found the number of pipes. So that'll actually be np.max pipes, because we're fitting it from the array, and we're going to go from every column, or every row in columns 0 to 2, which is, in the syntax, it'll be from 0 to the first and the second column. And we want to interpret that as 32, which will be the integer, and we want to add 1 because it's 1 more than any indication of what it is. Do that. To run it. See how many nodes we have, see if it's correct. 4, correct. Sweet. So we can move on. Now we want to find the internal indices. This will be just, this will allow us to know what indices of our nodes are internal. So I'm going to find that out by the number of nodes Okay, now that we have that, subtract the external nodes, and this will give us the number. This will give us the indices that are external indices. This will give us the amount of indices that are on the inside. So if we want to say like the number of internal indices, that'll just be equal to the length of our internal indices list. So got that. See how many that's correct. We have 2 internal nodes, which are internal indices. All right, so let's keep going. Now, let's incorporate that Z guess here. So we'll make an array for Z. We're going to start every array at 0, and it'll be the number of nodes. Now that we have that, we're going to set the function z, we get the array with 15 as our first, like we said here, and the rest are zeros. And we know that. So now we can make a flows array. It'll be similar to the last array that we made, but this time it'll be the number of pipes and not the number of nodes, because the number of pipes are where the flows are. But on the other note, we can make an array for the net flows, and this will be the number of nodes that we have, because there's a net flow for each node, but not for each pipe. They just have flows going through them. Now we'll make a P. A P array, and that'll also be the number of nodes, because the nodes are what have the P's that we have. And then I'll make a heads array, and it'll also have placeholders of zeros, and that will be the number of nodes as well. So now that we have this, finally we can set P, the external P indices. Those will be equal to the external pressures, as we defined right up here. So now that we have that, this would be helpful in another situation if we had external pressures other than zero, but just incorporated in this code to show you what it does. Now we want to find the internal head guess and the internal pressure guess. So to do that, we'll start by taking the average external head. This will help us. It'll be the external P divided by rho divided by G plus Z external P. And now we have this. This right here, it'll give us a 0 because all of our external pressures are 0. But here we have a guess for Z, so that'll allow us to get a good guess. So, well, get a good guess. So let's see what the average external head is. 7.5. Sweet. That works. So now we have an internal head guess, and we'll base that off of the average external head guess. This will be an array, E dot full. It'll be the number of internal indices like we made before, and it'll be filled with the average head, average external head, like we calculated before. So now that we have that, see what the there we go. Oh, wow, really butchered that one. Okay, internal head guess. See what we get. And it's an array of what we just calculated, the mean. So internal. Now we want to get the internal P guess, and we'll get that by taking the internal head guess, subtracting Z, and the internal indices of Z, multiplying that by rho and G. So now we have our internal P guess. Let's see what we get. Now we have a solid guess for the internal pressure, the pressure of the internal nodes. So now we can finally move on to our function to finally get the net flows. So first, to get the flows and net flows. First, we need to define the function. We're going to call it Q to 0 because it'll be iteratively getting the answer for us. Now we'll take the internal P in with it. So first, we're going to make all of these global. We're going to make these things that we made earlier global, so our calculations will not be messed up. Z, why not? Okay, so we want to set the internal, we want to set the p-values for the internal indices equal to the internal P. And now that we've done that, no, not P guess, internal P. There we go. Is now going to be equal to the, it'll be our pressure divided by rho divided by G plus C, because that's the definition for our head. Now that we've got that, we can make our for loop. And this will be a for loop for the number of pipes, because what we want to find is we want to find the flows in the system. And we'll do that by first calculating the delta head. To the head. First, we're going to find the heads of the to node minus the from node. So in that case, we'll do the to node of whatever iteration we're on minus the from, or minus the head of the from node of whatever iteration we're on. We also want to find the flows of whatever iteration we are on. So it'll be equal to the flow function that we made earlier. It'll take delta head, then it'll take the length of whatever iteration, the k, whatever iteration, the d of the iteration that we're on, and the pipe ed, whatever iteration we are using. So after this, we don't have any errors yet. I don't think we do. Now we want to fill our array for the net flows, because we want to fill every time, because it'll be running iteratively, and it'll be running iterations, and this will allow us to converge to a single value. Now we want to add at. This is adding into the net Q array. We want to add the to node, and we want to add the value flows that we calculated up top. So we're adding it to the net flow array. Now we want to do the same thing, or a similar thing, for the from node, but this time we're going to subtract, because if we do that, that's just how it works, because we are subtracting it, like right up here, instead of adding it like we are the to node. Lastly, we want to add our known flow rate to our net Q. Those will be at places 3, 3, and the values will be 0.005, 0.05, and 0.00025. Now that we have that, we are almost done. Now we want to return our net Q to internal indices and hope that works. Finally, we want our results, which will be equal to the roots, which I imported earlier, to 0, internal, P, guess, internal, P, guess. Now that I have that, we can see if it runs, and it looks like it runs, and we can see what our rough answers are. So now I'm going to make the answers a little prettier, and I'll get back. Now that we have something to make it look better, we can run it. That. Now let's run it. And these are our answers. So we were given the pressure of each node right here, the net flow rate of each node, and the flows of each pipe segment. Thanks for listening, Dr. Ko. I'll see you on Monday.